In this video, we will be looking at how you can import and export 3D data into our Vectric software. We'll begin by looking at the various file formats that you can import into VCarve and Aspire, and then later on we will cover file formats that can only be exported into Aspire. To begin with, though, we will need to start with a new job so that we have somewhere to import our data into. Let's close this project and start a new one. Let's create a new file and set up the width as 10 inches and the height as 10 inches. And we'll go with a material thickness this time of 0.5 of an inch. We'll set the Z0 at the material surface and we'll keep the XY datum position as the lower left corner. As we're going to be working with 3D models a lot in this project, we'll switch the modeling resolution to very high so that we can get a better result with our 3D models. With our material setting, we're just going to keep it as a Canadian maple, and we'll click OK. And so now we're into our project. Now we're going to be using the modeling panel and the Clipart panel. Now, one thing to note is that currently we're using the VCarve software here to demonstrate this. The options that we will be covering in this tutorial for this first section will apply to VCarve and Aspire. However, the Aspire modeling panel contains more features and options, so please keep an eye on which icons we're using in these steps, as the Aspire users will have more icons to navigate around. We will be covering the Aspire modeling panel later in this video as well. Let's go into the Clipart panel. And here you can see a large number of V3M Clipart files. These V3M Clipart files are specially designed to work in our software. Please refer to the video linked below to see a Clipart guide for both Aspire and VCarve software Clipart packs that you will receive. Once installed, they will appear here in this library folders. However, if you have an additional set of Clipart that you've purchased from another source and have these in a folder on your computer, you can use the Add Folder option to install these into your Clipart browser. Clicking this will open up a file browser to allow you to locate the folder that you have stored your Clipart in on your computer. This will allow you to then add it to your library folders so that you can then use the Clipart browser at any time to view your Clipart easily within the software. Clicking on the folder name in the Library Folders panel, you can see a full list of all the different categories that are contained within it, and all of its Clipart. Clicking on each one will bring up all the options within it for that category. As you can see, we have a number of different choices that you can choose, including some 2D options that are CRV project files that contain 2D vectors only. More commonly though, we have large collections of 3D Clipart. In many cases you can see they come in 3 varieties, although some are more unique. To work with these within the software, all you need to do is click and drag the Clipart from the Clipart panel over into your 2D or 3D view. Letting go of the mouse button will allow you to drop it into the project, and from there you can see that we have our 3D item already within the software. Let me just delete this. An alternative you can do is just double click on the Clipart file itself. This will automatically drop it straight into the software in the center of your work. Let me delete that once more. And then finally we've got the last import option, which is to right click on the Clipart picture you want and then use the import to level option. You can choose to create a new level or just import it to the standard level one. As you can see there, we've got it imported. So I'm just going to delete that out, and we can move on to the next section. So now that we've seen some of the standard options in the Clipart panel, let's go back to the modeling panel and we can now look at importing more varieties of 3D files. So we want to click on the Import 3D Models icon here, and this will bring up a Windows folder, which you can then use to navigate to where your 3D file is located. As you can see here, we've got a V3M file of a fleur-de-lis model, and then another format which is STL, which is a common 3D format that we can use. For a full list of all the 3D files that we can use, come down to the options here, and here you can see it says all 3D files. If I click on this, it gives me a full list of all the different file formats that we can operate with. If we're working with an imported V3M file, we just click on it and click Open, and this will drop it into our job at the origin point. We can then move it around, operate on it just as we would with any normal V3M clipart file. Let me delete this, and then we'll go into the more advanced file options, which are not native to our software. So I go back into the Import a Component or 3D Clipart option again, and I'm going to click on the Porsche file that we have here. When I click on Open, the software will import a version of the 3D model into my space in the 3D view here. There is nothing in the 2D view yet, as there is no 2D data yet to work with. Now, before I go any further, I'm just going to maximize the 3D view, as we're going to be working in our 3D view primarily for the next section. Now, let's go over our import 3D model form that you can see here on the left, as well as what you are seeing in the 3D view here. The first key feature is this wireframe. This is our material space for the project that we have set up. First of all, let's look at our initial orientation. Currently, we have the top of the car facing upwards out of the material, and we can adjust this by clicking on some of these initial orientation options here. The goal with these options is to try and orientate our 3D model in such a position that it will be presenting this face with the most detail upwards compared to our material space. As the tool is going to be cutting down into the material space, this is where the most detail will be able to be cut from. So we don't want to be presenting, for example, a large flat panel which won't have much detail on it, as any details on the sides of the model will be obliterated when it's imported. We'll get more into that later in the positioning section of this form though. And for a design like this, I think we would probably be trying to cut the sides of the car, as this has the most detail for our 3D toolpaths to work with. If we need to fine-tune this orientation, we can use these rotational circles to try and achieve the best orientation. As you can see, we can freely rotate it in any angle we choose. However, I'm just going to use the default front initial orientation in this example. If I need to, I can also choose to rotate around the Z-axis, but I will keep it at 0 in this case. Next, we want to talk about our model size. So, as you can see, currently this model does not fit within our material boundaries, and we would probably want to keep it within those material boundaries as we want to cut it. Here you can see the Z, X and Y dimensions of our 3D model. The X-axis, which is the length of the car, is currently 14 inches. I'm just going to select this X value here and change it to 9 so that it fits within the 10 inches width that my material is. As you can see, by changing the X, Z and Y have both automatically updated themselves to keep themselves within the correct ratio for our XYZ. This is because I have the Lock XYZ ratio option turned on right now. With most 3D models, you'll want to keep this turned on, but there may be rare occasions where you want to turn this off so you can adjust only one of the axes. Let me just click Apply for this now. And here we go, I'm going to turn off this option and just change one value to show you what this could result in. If I reduce this down to 4 and click Apply, you can see my car has now been squished in the X-axis only, whereas the Z and Y have not been altered. Let me put this back to 9 and click Apply once more. Next, I can tell the software what units this file is using. Currently, STL files don't generally tell the software what units they were actually created in and are only just a series of numbers. So sometimes we do have to tell our software what units the original file was designed in. For example, at the moment it is set to be 9 inches wide, but I can switch it to millimeters, and as you can see it's now only 9 millimeters wide, shrinking in size. Inches is correct in this case though, so we shall keep it as inches. Center model allows me to move the model to the center of the design space, and then I can also choose to scale it between inches and millimeters. So right now this is set to be 9 millimeters wide, but you're just seeing the values displayed in inches still. Let's click that to return it back to its original size. And now we can move on to the position and import section. And as you can see, we have this new element in the 3D view to consider. This is the position that the model is relative to the modeling plane of the software. As you can see here, this is controlled by this slider here on the side. Alternatively, you can choose to type in a value yourself if you wish to. For example, number 1, and I press enter, and the model will drop down a bit. You can see that we have the option to turn on discard data below 0 plane. If I turn this on and then move the model down, when this is imported, everything below this blue plane will be deleted out of the project. And by changing the sliding bar here, we can choose how much or how little of the model we want to keep. For example, if I pushed it all the way down, this would actually import a blank model because there is no data left above the modeling plane to import. Obviously, we don't want to do that in this situation. So let's turn off this option and turn back on the create both sides, as we are planning to make a two-sided model out of this in two separate sections in our single-sided job. We do have another video which is based on a two-sided job which follows many of these same steps, so please check this out in the related videos below. So I want to make sure that the plane here is in the center of our model so that both sides are equal in height. So if you double click on the dashed line in the center here, it will place it directly in the middle. This works for every one of these three lines. So just for a quick example, there we go, you can see it has been pushed right to the bottom, right to the top, and back to the middle. I should also point out that if you are importing a 3D model which doesn't have any details on the back side, you would want to make sure to turn off the Create Both Sides option and then move the modeling plane slider as low as it can go. This will ensure that the detail of the 3D model will be incorporated into your 3D component. We can also highlight any undercuts. So if I turn this option on, you can now see that there are some purple highlights in our design. These are indicating where the tool will not be able to reach when it is trying to cut, such as the details inside these wheel arches here, where the tool would be unable to cut the underside of these spokes. In many cases, this won't actually affect the final cut, but it does help you identify some potentially problematic areas in your design. If I turn off the Create Both Sides and update the undercuts, you can see that this increases the amount of areas which are going to be issues, as the software is now only considering cutting from above, rather than splitting the model in half and cutting them both from above on the same side. Let's create both sides once again, and just import it as it is. As you can see, it looks like a bit of a mess at the moment. This is because we have both the top side and the bottom side on the same side of the material overlapping each other. If I flip to the double-sided view, so we can see both the 2D and the 3D, you can see here in the 2D view, we have both sides of the car here. I'm just going to select the top side and use the transformation tools to allow me to then drag it up in our workspace. And then likewise I'll do the same and drag the bottom side down in our workspace so that they are nicely separated from each other. As you can see, they are much more identifiable as a 3D car object now. So I'm just going to maximize the 3D view again so we can have a closer look at our 3D model that we've imported. I'm just going to scroll in with the mouse wheel and then just pan the view down so that we can have a close look at our bottom side of our car here. As you can see, the 3D model has retained all of the original detail, including the polygonization of these wheel arches, making it look quite rough in our 3D file. This is unavoidable as we're importing the 3D model exactly as it was originally created. We'd want to go back to the original model and clean it up in our original 3D modeling software before importing it for a better finish, as we cannot just use a simple smooth algorithm to try and improve this. If I was to apply a smoothing filter to this model, as you can see, we're beginning to lose some of the detail on the wheels, even though the wheel arches are smoother now. So let's close that and ignore the smoothing for now. Another point to keep an eye on is anything that involves undercuts. Since it's not possible for a CNC machine to cut underneath a part of your model, since it would have to cut through from the top, certain elements become merged with anything that's below them. In this case, these wing mirrors are now merged with the window that was underneath them. Likewise, if we move to the front of the car, you can see that the front lights are no longer separated from the body and are now a single line straight down across the bonnet, as are the wheels, which continue all the way through to the center of the model. One interesting point as well is the aerial from the top of the car. As you can see, this is now forming a solid line straight down. And elements like this will need to be addressed as you move forward with your 3D models. Aspire users can look at reducing the amount of undercuts using this segmenting feature to break up the model to help minimize the number of undercuts. For more information on that, please look at the 3D Importing 3D Data Segmenting 3D Models tutorial for more information. Also, with a model, you can now have the option to right-click on the model name, and if it's an imported model, you can now use the re-import option. This will allow you to return to the Import 3D Model Positioning panel so that you can make small adjustments before then importing it again with these new settings, rather than having to delete the 3D model and import a new version of it from scratch. I'll cancel for now though, but you could now plan out some 3D toolpaths and a profile cutout toolpath to cut out these two parts and then glue them together to create your simple car design model. Let's move on to the next element now. This next section of the video is going to be about our Aspire software and its additional features and options that it has for 3D imports. Let me go and open Aspire. And let me set up a project as we did before in our VCarve software. So we're going to open it up and have a width of 10, height of 10, and a thickness of 0.5 inches. We'll keep the material surface as the Z0 position, and the XY datum position will be in the lower left corner as before. And we'll have our modeling resolution set to very high, and our material settings, we'll leave that as Canadian maple. All of this is in a single-sided project, and we'll just click OK to set ourselves up in the drawing panel. We'll switch over to the double view, so we can see both the 2D and the 3D together. And now we can start importing some 3D files through the modeling panel and using the Import 3D Model options. As you can see, there are quite a few more options here, but we'll be focusing on this import tool mostly today. The first thing we're going to cover is the difference between CRV3D files and 3D clip files, both of which Aspire can use. Here you can see two of them in our open folder. If I hover over this file, you can see it says it's a Vectric 3D clip file. And next to it you can see I have a CRV3D file, which is the native format for Aspire files. I'm going to open the CRV3D file first. And you can see here we've got the 3D component which was in that original project, imported as a new 3D component in our new project that we have running here. Then if I go back into the 3D import tool here, I can then click on the 3D clip file and use open on this. As you can see, this is imported slightly differently. While they both look the same in the 3D panel, you can see in the modeling components list here, the 3D clip file has imported in as a group of separate components, whereas the original CRV3D file has imported as just a single solid component. If I hide this component, you can see the entire section disappears and reappears when I make it visible again. Whereas with the 3D clip file, I can hide smaller elements of this. This way, if you export your designs as 3D clip files, you can keep them as their separate elements for future work in larger projects with your clip art that you have created. We'll be covering how to export 3D data later on in the video. For now though, let's just select all of our 3D components and delete all of this out of our project for the moment. Next, we're going to want to learn how to import a 2D bitmap and convert it into a 3D component. You can use this on a bitmap you already have in your project and use this create a component from the selected bitmap tool. Or you can use this to actually import a bitmap directly as a 3D component. This works best with 3D grayscale height map images, which you can see here in the open window in front of you. If I import this and just click open, you'll see that a 3D image has been imported and created and looks very similar to our original fleur-de-lis that we were working with. Because of the special way that grayscale height maps are created, it allows it to create these 3D items from just a 2D picture, which is not possible from normal photos, unfortunately. Let me delete this out for the moment, and I'll just go into the drawing panel and use the bitmap import option. I'll use this to import my post, and this is importing it just as a normal bitmap. As you can see, it's a normal bitmap within my software, which I can scale as usual. Now, if I go back to the modeling panel, I can now, with this bitmap selected, I can now click on my creator component from the selected or imported bitmap tool once again, and it will instantly create it as a 3D component. As you can see, this doesn't look like a 3D model of a wooden post, but it does look like we could use this texture as part of a larger project, as this is a 3D component in its own right still. One other thing to note is that the original bitmap still exists separate from the new 3D component, so we can easily remove this out of the way and delete it if it's no longer in use. The 3D component can then be altered like any other 3D component within the software, such as using the different combine modes to alter how it will behave with other components in your 3D modeling menu, such as a subtraction, or just setting it to add on top of everything else. It would also act as a texture overlay for another component. For example, if I import another piece of clip art, such as this apple, and then switch back to the modeling panel. If I put the apple underneath the post, you can see the texture now lies over the top of the apple, and if I were to work further on this and cut it out, I could achieve an interesting result. Let's delete these out for the moment though. And finally, there is one example I just want to show you. Let's go to create a component from the selected or imported bitmaps again, and import a bitmap straight to a 3D component without importing the bitmap step first. As you can see, we've imported this house, but as we move it around in the 3D view, you can see it doesn't have much of a 3D quality to it for carving a low relief of this house. But you can see it's picked up all of the different gradients and textures of the original picture. We could probably apply a smoothing to this, just a light one to take off some of the edges of the sharp corners here, and then we could use this as perhaps for a lithophane carving. But it's important to remember that the quality of the 3D component you create from your bitmap images that you import do entirely depend upon the quality of the original picture. If you have a low quality JPEG image, for example, you'll get some artifacting which will appear into the final piece that you create. Whereas if you use a higher quality format such as PNG, for example, you might get better results, particularly if it's a larger picture. So now that we've gone through a number of ways that you can import 3D data into VCarve and Aspire, let's talk about how you can export some 3D data from Aspire. So I'm just going to delete what we've created so far and maximize my 3D view. Now, usually we're using our software to create our projects, which we then turn into toolpaths and cut on our CNC machines. However, sometimes we want to save sections of a 3D component that we have created to reuse in future for other projects. That's what we're going to be covering now. So to get started, I'm just going to import another piece of 3D clip art, one we've worked with before, our 3D clip file for the fleur-de-lis. So if I click open, we import it in as the separate sections. I'll press F9 to center it in my workspace, and as you can see, I've got my 3D component. I can turn on or off any of these sections as I need to. But to export it out as another 3D clip file, for example, if I just want to keep this center fleur as a separate component of its own, I would want to have this as its own separate component. So let's ungroup these components. Then I just need to select it, right click it, and then use the Export as 3D clip art. I can then name it as a 3D clip file, although it will take the component's name as a suggestion for the file name. So if I just click save, that has now exported it out as its own 3D clip file, which I could then import back in again. And as you can see here, we've got it here sitting in our tutorial folder. And if I import this in, it comes in its own new separate section, which I could then move around and work with as its own part. I'll delete it for now though. If you have a number of components that you want to export as one solid piece, then what you want to do is select them all, right-click them, select Group. On the name of the group itself, right-click, and use the Export as 3D Clipart option again. This will export the whole group as one complete file, ready to import back in again for other projects. I won't do this time as we already have this file, and I'll just cancel for now. Next we'll look at exporting the selected group of components as an STL file. Back up here in the modeling panel, you'll see that we've got the Export Visible Model as an STL file option. If we just click on this, it'll load the STL export panel, and we just want to click triangulate to get an idea of what we're working with initially. As you can see here, we've now created an STL mesh in the software. It currently has got an open back, and you can see it's made up of a number of polygons. You can increase the tolerance of the 3D model by either changing the tolerance value here. So if we decrease the tolerance and triangulate again, you can see we have a slightly smoother result. And if we check the number of tries created, or triangles for short, you can see we've just got over 28,000 triangles here. Whereas if we increase the tolerance back up once more and triangulate again, you can see we've got just over 11,000. So you can get a higher quality STL file by decreasing the tolerance value, but at the expense of creating a larger file at the end. Or you can choose to use the maximum number of triangles as the measure of the quality of your final file. So if I leave it at 50,000 as the triangle number and click triangulate, it will use 50,000 triangles to create our final piece. And as you can see, with 50,000 triangles, this is much smoother than the previous attempts. Next, we can then choose to leave it open at the back, as we saw before, or we can close it with an inverted front, which gives it a full 3D look with a symmetrical front and back. Or if we now choose to close the flat plane, as it suggests, it just has a smooth flat back. So depending on what you want to use your 3D model for, that will determine what sort of back face is suitable for your design. Once we have set up our STL export as we want and the quality is suitable within our 3D view, we can then click on Save Triangulation to save this STL file. In this case, I should just call this the fleur and click Save. And as you can see, it's going to save as an STL. We can choose to save as an OBJ or a POV, but STL is the usual common one that I would be working with in my own projects. So I shall click Save, and that file has now been saved onto my computer. But let's close out of the Export Model option for now. So now for this last part, let's switch to the two-sided view and just look straight down on our 3D component. What we're going to do is export out our 3D component as one of these special grayscale height maps, which we were able to import earlier. This can be done by just selecting the group name for our 3D component, or if we have an individual 3D component, just selecting its own name from the component list. Then we can just go to the modeling menu, and we just use the option Export as Grayscale Bitmap. When we click on this, we'll go to our Windows save screen as normal, and we can then choose a name for our file to save it as. In this case, I shall call it bitmap. And as you can see, we can save it as various file types again, which is the bitmap, JPEG, GIF, PNG, or the TIFF file formats. When working with 3D height maps, I would typically use either the bitmap, the PNG or the TIFF formats, as these contain the highest quality images for 2D images. So I shall save as a PNG for the moment and just click Save. Now, if I go back to import a bitmap, you can see here I have got my bitmap image and it looks very similar to our original test. So if I now click Open, you can see my bitmap image has been imported and contains my 3D model as it was exported from our software, which I shall now delete. And this will conclude our tutorial on how to import and export 3D data into your VCarve and your Aspire software.